What I'm going to do is give you a point 3 comma 4, and what we want to do is identify and plot the point that is symmetric with respect to the x-axis, y-axis, and origin to the point 3 comma 4. So what we have here is the point 3 comma 4. If I wanted to find the point symmetric to the y-axis to 3 comma 4, you recall that symmetry with respect to the y-axis means that if xy is on the graph, so is negative x comma y. So negative 3, 4 is symmetric to the y-axis of 3, 4. If I wanted symmetry with respect to the x-axis, remember that says that if xy is on the graph, so is x negative y. So if 3, 4 is on the graph, so is 3, negative 4. Finally, for symmetry with respect to the origin, if xy is on the graph, so is negative x comma negative y. So if 3, 4 is on the graph, so is negative 3 comma negative 4. Now let's do the next component of the now work. In this problem, what we want to do is determine A, the intercepts of the graph, and then B, determine whether the graph has any type of symmetry. Well, we can see by inspection that the x-intercepts of the graph are negative 1 and 1. There are no y-intercepts. Also by inspection, we can see that I have symmetry with respect to the y-axis, because if I took this branch of the graph and flipped it over the y-axis, I would end up on this branch of the graph. In addition, I have symmetry with respect to the x-axis, because if I took the top half of the graph and flipped it over the x-axis, I would end up on the bottom half of the graph. Because I have symmetry with respect to the x-axis and symmetry with respect to the y-axis, I necessarily also have symmetry with respect to the origin.